Okay, so solving systems of equations, just a quick review of some different ways to do that. First off, if you have one that's already solved for a single variable, it's a lot easier to just sub it in. This is y equals 2x minus 7 and 2x plus 3y equals 11. I know what y is. It's 2x minus 7. So I take this and sub it in for y. If I rewrite it, it's 2x plus 3 times 2x minus 7, and that's equal to 11. I distribute the 3, so that's 2x plus 6x minus 21 is equal to 11. That would be 8x is equal to a positive 32, so x is equal to 4. Once I have x is 4, I bring it back up here. 4 times 2 is 8, and 8 minus 7 would be 1, so y is 1. So this is 4, 1 as a single point. I check to make sure it works in the other one. 4 times 2 is 8. 3 times 1 is 3, and 8 plus 3 makes 11, so this is a good answer. On the next one, I've got them set up, x plus y equals 5, and x minus 3y is equal to 7. So this is already set up for elimination. I can do that a couple different ways. I could multiply this entire top equation by a positive 3. It would make the y's eliminate. I could multiply the bottom equation by a negative 1. It would make the x's eliminate. I could multiply the top equation by a negative 1. It would also make the x's eliminate. It's just a matter of what I want to deal with and how I want to deal with it. In this case, I'm going to go ahead and make this top one negative because it's going to, whatever. So negative x minus y equals a negative 5. Negative 3y minus y is going to be a negative 4y is equal to 7 minus 5 is 2. So that gives me a y is equal to a negative 1/2. Okay? Even though it's a fraction, it's going to end up being the right answer. So a negative 1/2 in up here with the y, that would be 5.5 for x, positive. So x is equal to 5 and 1/2, or that would be 11 halves. If I go to check it in this one, 11 halves minus 3 halves would be, what just happened? Oh, 11 halves minus negative 3 halves, so that'd be 14 halves, which would be 7. Yeah. This one checks out. So it's 11 over 2 and a negative 1/2. Make sure you follow the signs on stuff like this, especially for multiple choice, because I made the answers myself on that one. So probably the positive and negative versions will both be in there. On this one, when you have a system of 3 equations, it's going to take you some room on the page. It's going to take some effort, but you have to figure out what your key equation is. In this one, the x's and y's kind of change through here to positive, negative, different numbers and whatever, but the z is always the same. So the easiest thing would be to take this one and make it negative, combine it with both of them. So I've got 2x minus 2y plus z is equal to 5, and then a negative x minus y minus z is equal to a negative 6. In this way, I can make it to where the z's are gone. 5 minus 6 is a negative 1. A negative 2y minus another y is minus 3y. 2x minus x is x. So I have x minus 3y is equal to a negative 1. So I've got one equation. Then I combine it with this one. So 4x minus x is going to be 3x. 3y minus y is going to be 2y. And then z minus z is going to be nothing. A negative 6 and 14 is going to go together to make 8. So I have 3x plus 2y equals 8, and x minus 3y equals negative 1. I could again multiply and do this one by elimination, just like I was doing right here. But since I just have a single x here, it's probably going to be easier to go back to like this and do substitution. So this is going to be x is 3y minus 1. I know what x is. I take this and I sub it in for x. So it's 3 times 3y minus 1 plus 2y is equal to 8. So that's 9y plus 2y is 11y. This would be a minus 3, go around the other side and make 11. So I've got y is equal to 1. Now that I have y is 1, I'm not going to go back up to the top. That's way too much work, that's too much time. I take it and I put it here. 3 times 1 is 3 minus 1 is 2. So I've got x is 2. And now that I have 2 and 1, I can go back up here to this easiest equation. 2 plus 1 is 3. So 3 plus a number makes 6. That means that z is equal to 3. And I write this as an ordered triple, which would be 2, 1, 3. Now, there's a couple of questions on the test that are gonna be word problems, so you'll need to make sure you know how to set them up. Refer back to the word problem paper that we did. If you haven't finished it, it might be a great opportunity to do that. The other thing that you need to understand is matrices. And when we're going over the matrices, it's just, you have 3 of them. The first one is the coefficient. It's the coefficient matrix. It's made of the coefficients. So it's 1, 1, 1, -3. The numbers in front of x and y. The next one would be your variable matrix, which is x and y. And then the last one would be your constant matrix or your answer matrix, and it's 5 and 7. The answers that are out here. Hopefully that gets you everything you need for the test. This will probably be in the classroom, or if you're subbed on YouTube, it'll show up.